Welcome to this fast-paced explainer on the peptide proof report. Today we're exploring exactly where peptide science meets real-world application. It's going to be data-rich, it's going to be authoritative, and it is entirely evidence-based. Okay, let's dive into this because, pretty much every peptide serum out there makes the exact same bold promise, right? They all claim they'll dive deep into your skin's layers to trigger collagen or iron out those expression lines. But look, we're not here for the marketing fluff. We're here to look at the biochemical reality of how peptide skincare actually works.
So how exactly do peptides get through your skin in the first place? Honestly, it's a question almost nobody asks out loud, but it's absolutely crucial. See, the outermost layer of human skin, your stratum corneum, is literally an evolutionary fortress. Now, it's incredibly thin, only about 10 to 20 micrometers thick, which is thinner than a piece of paper. But its primary biological purpose is just to keep things out. Water, pollutants, bacteria, and yep, your super expensive peptide molecules, they all hit this exact same formidable wall.
And here's where the harsh reality check comes in. Less than 1%, right? A study published in the Journal of Controlled Release back in 2019 found that unmodified peptides typically achieve less than 1% penetration through intact human skin. I mean, let that shocking number sink in for a second. Less than 1%. When you slap on a standard unmodified peptide serum, the vast majority of those molecules literally just sit right there on the surface. They completely fail to reach the living epidermis, which is exactly where the fibroblasts they need to communicate with actually live.
And this brilliantly illustrates why that happens. We're looking at a fundamental biological mismatch here. Think of your stratum corneum as a brick and mortar wall. The dead skin cells are the bricks, and the layers of lipids or fats act as the mortar holding it all together. Now, this lipid mortar is intensely hydrophobic, meaning it completely repels water. But peptides naturally love water. They're hydrophilic. So a water-soluble peptide trying to pass through a fat-loving barrier is literally like trying to mix oil and water. They just can't navigate that maze on their own.
To figure out how to actually beat this barrier, we've got to look at the 3 laws of biophysics when it comes to penetration. First up, molecular size. The golden standard in skin science is the 500 Dalton rule. Basically, any molecule larger than 500 Daltons has an exponentially harder time crossing over. Most cosmetic peptides, they sit right on the edge of this, usually between 400 and 1,000 Daltons. Second is lipophilicity, which is just a fancy way of saying fat-loving. And as we just saw, lacking that is a massive hurdle. And third, charge. Peptides naturally carry electrical charges, but here's the catch. Because the skin's surface has a net negative charge, positively charged peptides will actually bind electrostatically right to it. So ironically, their positive charge completely traps them at the surface instead of helping them get through. So how on earth does the industry actually solve this? Enter the palmitoylation breakthrough. Seriously, if you look at the ingredient list of almost any serious peptide serum, you're going to see the word palmitoyl over and over again. This is the industry standard solution. Basically, scientists attach a 16-carbon fatty acid chain directly to the peptide molecule. By adding this little fatty tail, they magically turn a bare, water-loving peptide into a fat-loving molecule. You can kind of think of this palmitoyl group as a master key. It finally fits the lock of the skin's lipid barrier, allowing the peptide to just slide right into that fatty mortar between your skin cells.
Now, what's really interesting about this slide is the sheer scale of the improvement. It's genuinely striking. Research from Sadrema, they're the French biotech giants behind Matrixyl, along with a separate 2018 study in pharmaceutical research, quantified this beautifully. They proved that adding this 16-carbon palmitoyl chain increases the peptide's flux, which just means its actual penetration through human skin, by a massive factor of 8.3 compared to the raw, unmodified peptide. For sure, it's an absolute game changer for delivery.
But wait, the science gets even cooler here. This palmitoyl tail serves a brilliant dual purpose. Once the modified peptide is safely inside the skin, these naturally occurring enzymes called esterases get to work. They act like little scissors and slowly cleave or cut the palmitoyl group right off the peptide. This enzymatic cleavage gradually releases the active peptide over a period of hours, rather than dumping it all at once. It provides sustained biological activity. Sadrema researchers elegantly call this a built-in slow-release depot effect. It's so much better than a brief, ineffective spike that your body would just clear out immediately. Section 1. Beyond palmitoylation. Next-gen delivery systems. Let's keep moving. Palmitoylation obviously solved a huge problem, but biotech doesn't just stop there. We're seeing incredible next-generation delivery mechanisms hitting the market that push peptide penetration even further into the dermis. Check these out. First, liposomes. These are basically tiny little protective bubbles made from skin-compatible lipids. They encapsulate the peptide cargo, protect it, and then fuse with the skin to achieve 2 to 3 times deeper penetration. Then you've got cell-penetrating peptides, or CPPs, like the TAT peptide. Their whole job is to literally temporarily disrupt the barrier's ordered structure. They create this brief, totally safe opening for other peptides to slip through, which can actually increase penetration by 10 to 100 times. Insane, right? And finally, microemulsions. These are nanodroplets so impossibly small, like 10 to 100 nanometers, that they perfectly navigate the microscopic channels right between those dead skin cells.
Section 2. Expert Insight. Formulation Failures. Okay, let's shift gears for a much-needed reality check here. Because honestly, buying a product with the absolute most advanced peptide ingredient in the world is completely useless if the formulation vehicle itself is flawed. So the crucial point is, if your base is bad, your results are bad. The biggest offender, what we call the silicone trap. Heavy, occlusive cream bases loaded with silicones, like dimethicone, create a literal physical film on the surface of your skin. Now, sure, they feel incredibly silky and smooth, but if your goal is deep delivery, they're actively working against you. They will completely trap your expensive peptides on top of your skin, blocking them from ever passing through to the layers where they're actually needed. And then there's a much quieter, totally invisible threat: the pH problem. We have to remember that peptides are extremely sensitive molecules. Their entire biological activity depends on their delicate, three-dimensional structure. And guess what dictates that structure? The surrounding pH of the serum. If a brand skips rigorous stability testing to save a few bucks, an incorrect pH environment can literally unravel and destroy the peptide structure right there in the bottle, meaning the product is completely useless before a single drop even touches your face. Section 3. Real-world application. At-home tips. Let's move to and see how this builds into your actual routine. So let's bridge the gap between high-level laboratory biochemistry and your bathroom sink. Because yes, there are scientifically validated ways you can boost absorption yourself right at home. And the easiest method? It gives us this fantastic number, a 20 to 40% increase. Based on in vitro models, applying your active peptide serum to a hydrated stratum corneum increases penetration by roughly 20 to 40%. Why? Because a hydrated, damp skin barrier is just naturally more permeable than dry skin. It's a modest effect, sure, but it is very real, completely free, and super easy to leverage. So here is exactly how to do it, a fully actionable routine. Step 1. Cleanse gently. Step 2. Towel dry so your skin is only slightly damp. Step 3. Apply your serum within 60 seconds. But listen, the caveat here is critical. Do not apply it to dripping wet skin. Standing water will just dilute your active ingredients. Also, definitely avoid aggressive physical scrubs. I know you might think you're clearing the way for the serum, but you're actually likely causing microdamage and inflammation. And that inflammation, it triggers enzymes that will break down and degrade your peptides even faster. Definitely not what we want. Now, when you're standing in the skincare aisle trying to choose a product, here is your evidence-based shopping guide. First thing, look for ingredients starting with palmitoyl, like Matrixyl. That's your solid baseline. It proves the peptide actually has the necessary fatty acid modification to reach its target. Next, if you want to tier up to the advanced stuff, look for marketing terms like liposomal or encapsulated. And finally, always prioritize lightweight, water-based serums. If you flip that bottle over and the first 5 ingredients are heavy silicones and thickeners, honestly, just put it back. Those peptides aren't going anywhere. This field of biotech is moving incredibly fast, so let's take a quick look at the timeline for the future of peptide delivery. Happening literally right now, we have biomimetic peptides being designed from scratch using AI and molecular dynamic simulations. They engineer the absolute optimal charge and size directly into the molecule before it's even made. In the near future, we're going to see microneedle patches loaded with peptides, creating microscopic, temporary channels through the skin for massive penetration increases. And looking 3 to 5 years out, researchers at Harvard and MIT are developing ionic liquid solvents. These can safely and reversibly fluidize the lipid barrier, delivering peptides deep into the dermis at levels we previously only saw with actual physical injections. It's mind-blowing. Which brings us to our final thought for today. Based on the authoritative science we just covered, ask yourself, what delivery system is actually hiding in your serum? Armed with this evidence-based knowledge from the Peptide Proof Report, you're now fully empowered to scrutinize your own skincare routine, ignore all that marketing fluff, and demand products that actually deliver on their scientific promises. Thanks so much for joining me on this explainer, and keep questioning the science.